Yes, today in this class we will discuss regarding the elements of civil engineering and engineering mechanics part. So here we will go to module number 1. So basically we are discussing especially related to numerical part in this video sessions. So if you come to module number 1, generally in VTU examinations there are several basic questions. So in which we are having different varieties of problems. Which the first variety of problems are resultant computation. In the resultant computation, generally we are having two system of forces, that is concurrent and non-concurrent, and also generally here in this first steps we are discussing with concurrent, resultant of concurrent. In second, we are discussing on moments. In third, we are discussing on force coupled systems. So once generally in first varieties of problem we are discussing regarding only forces. In second, we are discussing in moment. In third, we are discussing force coupled system or force moment system. Force coupled system or force moment system. Overall, in the way that in module number 1, we are discussing only three varieties of problem. The first varieties of problems are related to forces. The second varieties of problems are related to moments. The third varieties of problems are related to force coupled system or force moment system. So now we are going on the first varieties of problems, that is resultant computation of concurrent force systems. So in this generally in VTU examination the problems are asked to compute the resultant of concurrent force systems. So the first problem is a resultant of four forces acting on a body as shown in figure. The resultant of four forces acting on a body is as shown in figure. The resultant of four forces. The first force is 200 Newton. Here the slopes are given. The second force is 120 Newton. Here also the slopes are given. The third force is 50 Newton. Here the inclination 30 degree is given with respect to y-axis. The fourth force is 100 Newton, and here the inclination given with respect to x-axis. So the compute the resultant of the given force system. So before going to this problem particularly, we must know the basics. What are the essential basics required to solve these problems? First of all, we require how to resolve the inclination of forces. Here all four forces given are all inclined forces. When inclined forces are given in a problem, we must resolve these inclined forces into pure horizontal as well as vertical forces. So to solve this problem, very firstly we must know the resolution concept. What is meant by resolution concept? How to do the resolution? This is a very important thing. Generally in examination, students are committed mistakes in these steps. They don't know how to resolve the inclined forces. So in the first step, I will explain how to resolve the inclined forces. So before going to solve this problem, I must explain resolution concept. So what is meant by resolution concept? So we know that generally we are having vertical forces. The vertical forces may be acting in upward direction or it may be in downward direction. Generally we are having sign convention, all vertical forces, upward forces are positive and downward forces are negative. This is the general sign conventions we are adopting throughout the mechanics, throughout the civil engineering. Generally we are assumption, it may be positive or it may be negative. But here to solve the problems, we are assuming upward vertical forces are positive, downward vertical forces are negative. Similarly, horizontal forces. Horizontal forces. So right side horizontal forces are positive, left side acting horizontal forces are negative. Right side acting horizontal forces are positive, left side acting horizontal forces are negative. So the only thing is, generally we are having only two types of forces. One is vertical, another one is horizontal. In vertical, upward is positive, vertical downward is negative. Horizontal, right side is positive, horizontal left side is negative. So this is the general forces. But in some cases there is a chances of inclined force. In the given system of forces, all forces are inclined forces. So then what we have to do? The inclined forces F, maybe with respect to x-axis theta, or the inclined forces F, theta 2, this theta 1, theta 2, it may be inclined with respect to y-axis or with respect to x-axis. So please keep in your mind when you are solving these type of problems, the possibility of inclination is whether with respect to x-axis or with respect to y-axis. Only two possibilities. The inclination of force, the possibilities of inclinations are only, the chances are only two inclination. Whether it may be in horizontal or it may be in vertical. So it may, in this case, it is inclined with respect to horizontal. But in this case, it is inclined with respect to vertical. Now, these types of forces are converted into purely horizontal as well as vertical forces. So, as I already told that the existence of forces to solve the problem, the only ways are vertical as well as horizontal. If in case they give the inclined forces in a problem, we have to resolve that inclined forces into pure horizontal as well as pure vertical forces. How to resolve? The resolution concept is very simple. The shortcut you have to remember to solve this kind of problem. There is an inclination with respect to x or with respect to y. Please remember while you are solving problem, always inclination angle is cos theta. The inclination angle is cos theta. The remaining one is sin theta. If you come to this problem, if you resolve, the chances is pure vertical and pure horizontal. And the one more thing, if in problem the given direction of force is very important. In this, the given direction is towards the joint. Hence here also the direction of the force is towards. But here in this case, this is away from the joint. Therefore, pure horizontal and vertical forces are also away from the joint. Then the thing is, the inclination angle is cos theta. The remaining is sin theta. Then after resolution it will become f cos theta 1 and it will become f sin theta 1. Similarly here the inclination is y-axis. Therefore y-axis is cos theta. The remaining one is sin theta. Here it will become f cos theta 2. Here there is no inclination. It will become f sin theta 2. So when you are resolving the inclined force, two things plays a major role. One is direction of the force, another one is inclination of the angle. Direction of the force, two possibilities, towards the joint or away from the joint. Inclination of the force, two possibilities. One is with respect to x-axis or with respect to y-axis. So here the direction inward. Therefore here the two directions are inward. Here the direction is outward. Here the two directions are outward. And the inclination is with respect to horizontal. Therefore horizontal is cos theta. Here the inclination is vertical. Therefore vertical angle is cos theta. So the two things you must remember, the direction of the force as well as inclination of the angle. This is the simple concept. And these are the sign convention. Upward force positive, downward force negative. Right side horizontal positive, left side horizontal negative. Now I am coming to this problem. This is very important problem. It's an 8-mark problem, computation of resultant and its inclination. So now I am going to resolve these forces. When I am observing these forces, here slopes are given, here the angles are given. As per my concept, I can apply the concept easily for 100 Newton and 500 Newton, 50 Newton force. First I will resolve these two things. If I resolve this, first direction is away with respect to joint. Therefore, this is away, this is also away. Next, here, this is also inclined force. Here also the direction is away. Therefore, this is also away from the joint. Now, this is 100 cos 50. Why is this 100 cos 50? Because as for shortcut I have explained that always inclination angle is cos theta. The remaining one is sin theta. Therefore, it will become 100 cos 50. The remaining is 100 sin 50. If you come to this case, now the vertical is inclination. The vertical inclination angle is given, that is 30 degree. Hence, it will become 50 cos 30 and it will become 50 sin 30. 50 cos 30, 50 sin 30. When you come to these two forces, slopes are given. When slopes are given, compute the angles. Consider this triangle. This is 200 Newton force. This is 1. Take this as theta 1. Apply tan theta 1. Tan theta 1 equals opposite by adjacent. Therefore, tan inverse of theta 1 equals tan inverse of 1. Tan inverse of 1 will become 45 degree. So the theta 1 value is 45 degree. So compute the angle. This angle is 45 degree. Therefore, this horizontal angle. Whatever I have computed, this is horizontal angle, right? Therefore, this is 45 degree. Now resolve these forces. Once again, away. This is away, and angle of inclination is x. Therefore, it will become 200 cos 45 and 200 sin 45. This is over. Then I am going to the last part, that is 120 Newton. For 120 Newton, just up here, so 120 Newton, the triangle is like this, 4, 3. Once again, the horizontal is theta 2. Tan theta 2 equals opposite by adjacent. Therefore, theta 2 equals tan inverse of 4 by 3. What is the value of tan inverse of 4 by 3?
53.13.
53.13 degree. Therefore, this angle is 53.13 degree. When you resolve this into pure horizontal and vertical forces, the first thing is also acting away. Please keep in your mind that if it is acting towards the joint, you have to represent these forces towards the joint. So now it's acting away from the joint. Hence, I am representing both the forces in the direction of away from the joint. Hence, it will become 120 sin 53.13. Why? Because it's inclined with respect to horizontal. Therefore, horizontal is cos theta. The remaining is sin theta. It will become 120 cos 53.13. And the remaining is 120 sin 53.13. This is the very first step. This diagram is called free body diagram. This carries your 50% of the marks. If the problem is for 8 marks, only this diagram carries a huge weightage of 50%. If you make a mistake in this diagram, you are losing complete allotted marks. So be careful when you are solving this basic problem. The thing is how to resolve the inclined forces. The resolution concept is very simple. First you have to concentrate on direction of the force. Next you have to concentrate on inclination of the angle. There are two directions, there are two angles of inclination. If the direction is away, represent away. If the direction is towards, represent towards. If the inclination is horizontal, then horizontal component is cos theta. If the inclination is vertical, then the vertical component is cos theta. This is the only simple thing you have to keep in your mind when you are resolving this problem. What is the ultimate aim of the problem? The ultimate aim of the problem is compute the resultant and inclination of resultant. What is the R? R is the resultant. That is sum of all horizontal as well as vertical forces. R equal square root of sigma fx square plus sigma fy square, and theta equals tan inverse of sigma fy by sigma fx. These are the two equations. The ultimate aim of the problem is to compute the resultant and its inclination. Resultant and inclination. Where sigma fx is the sum of all horizontal forces. Where sigma fy is the sum of all vertical forces. When you are doing this sum, the direction of force plays a major role. As per the direction, we have to incorporate the sign convention. All upward vertical forces are positive, all downward vertical forces are negative, all horizontal right side forces are positive, all horizontal left side forces are negative. So as per this concept, now I'll compute the sigma fx value. So for computation of sigma fx value, the general sign convention is horizontal force is positive, vertical force, horizontal left side force is negative. So please observe this system. We are having 4 horizontal forces. 1, 2, 3, 4. For this is positive because acting right side. This is negative because it is acting left side. This is also negative because it is also acting left side. This is positive because it is acting right side. So there are 2 positive, 2 negative. So do this sum. One is plus 200 cos 45. Next one is minus 120 cos 53.13 minus 50 sin 30 plus 100 cos 50. Now do this sum. How much?
108.7.
108.7 Newton. This is the sum of all horizontal forces. Next I am coming to sum of all vertical forces. For this sign convention is all upward forces are positive, all downward forces are negative. Because this is sum of vertical forces. Here we are having 4 vertical forces. 2 upward and 2 downward. These 2 are positive because acting in upward direction. These 2 are negative because it's acting in downward direction. Therefore, sigma fy equals plus 200 sin 45. Next, this one plus 120 sin 53.13 plus 120 sin 53.13 minus 50 cos 30 minus 50 cos 30 and minus 100 sin 50 minus 100 sin 50. Do this sum. How much you are getting?
117.5 Newton.
117.5 Newton. We computed all horizontal forces value. We computed all vertical forces value. Now easily if you substitute in this equation, we are getting the resultant and its inclination. Now resultant R equals square root of, what is sigma fx? 108.7 square plus 117.5 square. So we are getting R value. How much?
160 Newton.
160 Newton. This is the resultant. 160 Newton is the resultant. Now I am going to compute the resultant inclination. I am having the equation theta equal tan inverse of magnitude of. See what it indicates. It's a magnitude. Magnitude means if you are having negative value, even though you have to substitute the positive value, don't consider the negative value when you are computing the angle computation. Therefore, theta equal tan inverse of magnitude of sigma fy by sigma fx. Therefore, angle of inclination theta equals tan inverse of sigma fy 117.5 divided by 108.7. How much?
47.2.
47.2 degree. So this is ultimate aim solutions for the problems. That is, one is resultant. The resultant is 160 Newton and resulting inclination is 47.2 degree. One more step. Don't stop over here. When you are asking in examination, please show the representation diagram. How it represents. The thing is, we know sigma fx. Sigma fx is positive. Sigma fy is also positive. Sigma fx, sigma fy both are positive. Sigma fx is positive. Sigma fy is also positive. It will come in first quadrant. Both are positive. So what is the value of sigma fx? 108.7 Newton. What is the value of sigma fy? 117.5 Newton. Then the resultant lies in this quadrant. This is R value. R value is 160 Newton and the inclination is 47.2 degree. This is the representation of resultant. Representation of resultant. First, sigma fx positive, sigma fy positive. Within that first quadrant, R will lie. This is R value at an angle of 47.2 degree. So this covers the entire problem. This problem is for minimum 8 marks, maximum 10 marks in video examination. So this is called computation of resultant and its inclination by result parts. So just we are using resolution concept here to get one single force and its inclination. Thank you.